Three, two, one, go. Hello everyone, my name is Tanishq Sharma and in this presentation I will be discussing the production grade logging and error diagnostics in Flutter apps. This talk is part of the Liquid Galaxy streamings for the GSoC 2026 pre-requirements. We'll look at how to capture meaningful logs, trace failures and debug real-world issues without relying on debug builds or guesswork. The goal is simple, making Flutter applications observable, debuggable, and reliable in production environments like Liquid Galaxy. So let's get started. So what exactly is Liquid Galaxy? Liquid Galaxy is an open source platform for immersive multi-screen visualization. It was originally created by Google engineer Jason Holt to run Google Earth across a cluster of PCs. But it has since evolved far beyond that. At its core, Liquid Galaxy is not just multiple screens showing the same content. It is a distributed rendering and synchronization framework where several machines work together to behave like a single visual system. This allows real-time, high-resolution, and immersive experiences that would be difficult or inefficient to achieve on a single machine. Today, Liquid Galaxy is used for 2D and 3D virtual tours, geospatial data analysis, and interactive visualization systems, where precise synchronization across displays is critical to maintaining visual consistency and immersion. So now, what is Flutter? Flutter is an open source UI software development kit created by Google. It allows developers to build cross-platform applications from a single code base, targeting Android, iOS, web, desktop, and other platforms. So, we need to write code only once, and it can be done on all of these platforms. Unlike traditional frameworks that rely heavily on platform-specific UI components, Flutter renders its own UI, which gives it predictable performance and consistent behavior across devices. In the Liquid Galaxy ecosystem, Flutter is primarily used to build controller applications typically running on Android devices. These controller apps act as a remote interface for the Liquid Galaxy system, allowing users to trigger actions, navigate content, and interact with the panoramic visualization in real time. Because of Flutter's performance and rapid development cycle, it fits well for building responsive control surfaces for distributed visualization systems like Liquid Galaxy. Now, why I particularly selected this topic for my presentation. While working on a Liquid Galaxy controller, I was trying to debug a issue, and whenever I used print, I saw this error. Where it said, don't invoke print in production code, try using a logging framework. So that made me think that I don't know about a logging framework and I especially don't know about how to efficiently use it. And so I decided to make this video. So now, how does logging helps us? The most immediate use of logging is troubleshooting errors that occur outside your local development machine. For an example, let's say a user reports a crash, which you cannot debug because you cannot attach your device to the user's device. So you rely on logs to see the stack trace to pinpoint the problem that caused the crash and the state of the application leading up to that crash. Logs provide the data that will lead you to the point where your code failed and where the application crashed, and they will also allow you to reproduce the issue locally so that it can be solved. Next, monitoring health and performance. Logging isn't just for errors. It is also used for measuring the heartbeat of your system. Latency tracking. By logging the start and end time of a complex operation, you can identify performance bottlenecks. Logs can warn you if your application is running out of memory or hitting API rate limits. Next, it is also used to understand the application flow. In complex architectures, especially asynchronous ones like mobile applications or distributed systems, it is hard to mentally model the exact sequence of events. But logs help you to trace a request from the UI through the business logic to the database and back. In multi-threaded environments, logs helps you to identify race conditions by showing the exact order in which different threads executed different tasks. Next, logs are also really helpful for security and auditing purposes. For many enterprise applications, logging is a compliance requirement. You need a permanent record of who did what and when. And let's say in case you detect multiple failed login attempts, logged in rapid succession can trigger security alerts. Next, logging helps distinguish between network issues and server-side bugs. Uh, s- uh, so now, how to actually do logging in Flutter? Specifically for Flutter, packages like logging and logger are used. Dart also has the inbuilt Dart developer, which provides the log function for detailed logging. Now moving on to the next slide, why is print not enough? As we saw this is not really an harmful error, but it's not just a good practice to use print. But is that all? No, there are also other issues that are connected with print. So let us see them one by one. The logcat truncation issue. On Android devices, the system log buffer, that is also called the logcat, has a size limit. If you print a very large JSON response or a long error stack trace, which Android devices will simply cut off the text in the middle and you lose the most critical data. So, if an error occurs and it gives a very large error and it returns you a very large stack trace, so then it will be really hard for you to pinpoint the error as some data will go missing due to the size limit. But Flutter's debug print and specialized logging packages throttle the output, breaking large text into chunks so that nothing gets lost in the console. Next, performance. Performance is really important for any application. You don't want to see a loader for 5 or 10 seconds just buffering there and roaming around. You want your application to be fast. Print write, but whenever you use print, it writes to the standard output. In many environments, this is a blocking synchronous operation. That means it will hold your main thread and will first write the logs to the standard output, and after that your code will again execute from the point it was left. So, so if we leave print statements inside a heavy animation or a build method, it can cause frame drops because the UI thread pauses to write text to the console. But logging frameworks handle this log writing asynchronously or buffer the logs so your UI remains buttery smooth at 60 fps. Moving on to the next point, remote monitoring. Whenever you build your application for the Play Store, use simple print statements often remain active. Anyone with a USB cable and ADB logcat can plug in their phone and see your app's internal logic, tokens, or user data scrolling by. Logging frameworks allow you to configure things. You can set it up so that in debug mode, that is, whenever the application is in development, the logs go to the console and you see colorful, detailed data that will help you to debug the error. But in release mode, the logs are completely silenced automatically. You don't have to delete lines of code before publishing, and these logs can be stored on a remote server or in a database from where they can be extracted in case any error occurs to trace back the error. Let's say a user is in another country and the application is outside of the server's range and an application crashes. So now, how will you know what error occurred? Because the local console will not print anything. The data is gone forever. But a logger can be connected to a remote backend. Production logging levels allow filtering. As your app grows, you might have hundreds of print statements. Your console becomes a messy blur of different outputs and different logs. Some of them may be fatal errors, while some of them are simply log statements like user logged in or user logged out, making it impossible to find specific error that you need. Logging levels allow you to filter visibility instantly. You can filter out the fatal errors, the simple debug errors, and different logging levels. If you just want to see the network traffic, turn on the verbose mode. If you want to focus on a bug, just focus on the error and warn logs. This keeps your workspace clean without deleting the code. Now next, then what to do? So, how do we So, what are the common practices and common packages that are used, and how should they be used? So, the first is debug print. The debug print is designed to safely output debug information during development while avoiding console overflow issues, that is the locket issue that we talked about, especially on Android. As it occurs on Android, it automatically throttles the output to prevent log lines from being dropped by the system, unlike print. Only executes in debug mode. It is removed in release builds, making it safe for use without impacting production performance. Use it for logging large data, debugging widget trees, or stacking or tracking state changes without cluttering the console. Another way is using the logger package with Google Firebase Crashlytics. Using Logger to log the errors and Google Firebase Crashlytics to store them in the cloud in a smart way using grouping and temporary buffer is really helpful, as I will also show in the demo later. Next comes the Talker underscore Flutter package. I just got to know about this package a few days ago, and it's really useful. We can configure the app so that if you shake the tablet or long press a hidden logo, a console overlay appears on the top of the UI. This is useful in local setups. So let's say there's some bug or there's some issue in a museum where the Liquid Galaxy display is in use. So the developer can come, let's say he or she can press the logo of Liquid Galaxy 5 or 7 times, and then a console will appear. This will be useful to debug the issue locally. The other person could connect his or her device and find the issue and solve it using the stack trace that will appear. Now let us talk about different logging levels. At the lowest level, we have debug. Debug logs are extremely detailed and mainly used during development or deep troubleshooting. They are expensive, noisy, so they should never be enabled in production for long. Next is info. These logs describe normal system behavior, startup messages, successful request, configuration loading, user signed in, a data has been sent, KML file uploaded. All these can be logged using the info tag. They help us understand what the system is doing without overwhelming detail. Then comes warn. It indicates something unusual or potentially risky, but the system is still functioning. Think of resource limits, deprecated APIs, or attempts issues that may turn into failures if ignored. So let's say it's taking too long for your controller to connect to the Liquid Galaxy rig. Let's say ideally, it should take around half a second at max, but it is taking 5 to 6 seconds. Then that's an issue. And we can see and track back this issue using the warn logs. Error logs represents real failures. A request failed, a component crashed. Let's say the KML file wasn't uploaded, and how will you track back this error? Using the error logs. Finally, fatal is the highest level. These are unrecoverable issues, critical infrastructure failures that cause the system to shut down or crash immediately. Moving on to the next slide, observability. Observability goes a step further than logging. While logging tells you what happened, observability gives you the tools to understand why it happened. Google Cloud Observability is such a platform that offers cloud monitoring, cloud logging, cloud audit logs, and many other features. Observability does not only helps you to see the logs but understand the patterns in it. When is the traffic peaking? Is there any service that may bottleneck, or is there some kind of crash that may be affecting users repeatedly? We can see memory spikes, CPU spikes. If any error is recurring, we will not see the error again and again, but instead we will see a smartly grouped list of errors such that we see what's the error and how many times has it occurred. It helps us to pinpoint the exact issue and fix it. Now it's demo time. So moving on to the demo. So now for the demonstration, I've created an application that displays three different screens. One displays the print and debug print, another displays how to use logger and different levels, and then next is using talk underscore flutter with the Google Firebase Crashlytics. So let us see them one by one. This is the basic print that we should avoid using. It's the standard print as we can see here. Then comes debug print. It helps with the logcat issue, but it's not really the best way to do it. Now, if you are working on your, let's say, a normal project or just one of your personal projects, you can simply use Logger. It gives beautiful logs, as we can see here, with different levels, and they'll help you to debug the issue smoothly and faster. Next comes the level 3, that is the using the talker underscore flutter with Google Crashlytics. We can generate visual logs here. We can also open an in-app console here, and we can see all the logs accumulated right here. We can copy the logs and trace back the issue and solve it. After that, there's the force fatal crash button, which will replicate a fatal crash. This will send the log to the Google Crashlytics dashboard where we can view it and solve. This is really useful in production apps where you cannot really access the user's device. So let us see it once. This is the random dash logger. It is currently configured with this Crashlytics. As we can see currently one user and 4 crashes. So now the application crashed, and now if we come here and reload, crashes increases to 5, and we can see a flash issue right here. This is a test crash caused and all. So next I have also created a readme showing the method, the way I used to configure talk underscore flutter with the Google Firebase Crashlytics, as it was a really complicated process. So now I will be demonstrating in a fresh application how to actually follow this readme and configure your talk underscore flutter with the Google Crashlytics dashboard. So now I would like to show how the application was built and how to connect the talk underscore flutter with your Google Crashlytics to get the logs and see whenever your app crashes in production. So here I'm having an empty application. I created it using the Flutter new project command. I'm running Android emulator on Google Pixel 7, and I'm going to follow the commands in this readme.md. This is the application that I previously showed you, and this readme was created by me. So let us start with the first command. We will need all these dependencies. Install logger, as we'll also be trying out logger, talk underscore flutter, as we'll be trying it out, and Firebase core and Firebase Crashlytics to connect. Now as they have been installed, you can go to this firebase-cli link and see according to your system how to install the Firebase CLI, as we'll require it for connecting with the Firebase Crashlytics. As I'm on Windows and I have Node.js installed, so I can simply come here and install it using the npm install-g firebase-tools. If you are on Mac OS or Linux, you can go to the respective sections and see how is it installed. I have already installed it, so I'll skip the step. Next, you can run Firebase login and sign in with your Google account. After that, you can run Flutter Fire configure. the project's root like this. Now it might show you this error because we have not configured the Flutter path and saved it as a system variable. So instead of using this, I've also given an alternate. Yeah, you can use the dart pub global run Flutterfire CLI Flutterfire configure command. What this command is actually doing, the dart pub global run Flutterfire underscore CLI, we are actually accessing the Flutterfire CLI using the dart pub global. So we are actually running the Flutterfire CLI in the dart pub global environment and then running the Flutterfire configure command. So here I run this file. Now it will show you all these options. I would like to create a new project, but creating a new project may sometimes cause a weird issue. So instead of creating a new project from here, we'll go to the Google Firebase dashboard. We'll create a new Firebase project. Let us call it live-demo. Demo. Continue. Let us just continue and continue. Configure Google Analytics. Default account for Firebase. Create project. The project is in creation right now. Project has been created here. Now we'll come back to the terminal, run the command again. It is fetching the available Firebase projects, and now here I see live demo. I'll select it. As Liquid Galaxy generally uses only Android, so I'll be using only Android as the platform. Enter. Registering the new application as Android on the Firebase project right here. And it has been created. So now the next step we can see it from the README is it will ask you to create a new project or pick an existing one. We created a new one. We selected the platform as Android. A file will be generated at lib/firebase underscore options.dart. So now where can we see this file right here? Now this file contains these API keys, app ID, and all this. All this data may look like it is confidential data that should not be put up in any application or like pushed on GitHub, but actually these are just identifiers that are used by the Google Crashlytics to identify that the log is actually coming from this application and to where they will store the log. So it's not really a real harm if we push this if we push these API keys and app ID on GitHub, and we'll need to push them in our development app in our finalized production application for sure. But there's a method to not let them be misused, which I'll talk about later. So right now, to avoid someone, we'll set up an app check. Yes. So now we'll be setting up an app check. It will use the Firebase app check dependency. So let us quickly add this dependency. So what we are effectively doing is we'll create a SHA-256 a SHA-256 secret key. We'll use that secret key and add it to the Google Crashlytics dashboard. So only the applications that will have that SHA-256 key will be allowed to send their logs to our application. So no random person could just copy our API key, our app ID, and all this data and use it to send data or faulty logs to our application. Now the command is running. It's terminal, it's here. Okay.
So the dependency has been added. Now, uh, my bad. We'll do cd android. We'll go into the android folder. We'll do dot slash grad view. It's basically the same command here. Signing report. So this will generate a signing report, that is the key that will store in the Google Crashlytics dashboard. So the build has been successful and we can see the signing report here. We'll copy the SHA-256 key. We'll go to the console, live demo. We'll click this demo Android, this gear icon. We'll scroll here and here we can see add fingerprint. We'll add the fingerprint and it has automatically detected that is a SHA-256 key. Save, and the certificate fingerprints have been added. So next, and it's all written right here. Next, in the Firebase console, go to Build App Check. Select your Android app from the list and click Register and Play Integrity. Okay. In the Firebase console, go to Build App Check. This means Firebase console, Build App Check, then Apps. Yes. Get no, build app check. Yes, get started here, and we'll register our application. Play integrity. There's no need to add another fingerprint and save. So now the app has been registered successfully. The next step is in your main.dart file, we'll add this after the firebase.initialize app. So yes. So now coming back to the coding part, yes, first I can explain the code and after that we can see the 15th step. So now let me explain the code base to you. First, this is the main.dart file. It creates a basic home screen which will lead us to the next three screens, that is the native screen that shows the print and debug print, the logger that shows how the logger is used, to display visually appealing and easily filterable logs, and then comes using talk_flutter with Crashlytics. After that, here's the globals.dart file. It initializes an observer using Crashlytics Talker Observer. Now moving on to the Crashlytics Talker Observer. It uses the packages Firebase Crashlytics and talk_flutter. What it in simple words, what it is doing is whenever you get whenever you get an error, an exception, or a log, it creates an instance using the Firebase Crashlytics.instance and records the error in the following format: the error, its stack trace, and the message. And then comes the Crashlytics logger output. This file is being used to convert the logger output to something that can be to a particular data format that can be sent and stored on Google Crashlytics. As logger, as the default setting for logger is to just log its output on the console, but while sending the data, that is the data of the log, the stack trace, and the error on Google Crashlytics. So we change the format of the log that is outputted on the console to a particular format, which can be sent using the Firebase Crashlytics instance dot record error. Then these are the three screens here. This is a simple screen. On pressing a button, we see the print statement. On pressing another button, we see the debug print. Then comes log_screen. It utilizes the Crashlytics login screen, the Crashlytics logger output, and uses that to send the logs to the Crashlytics server. After that, this is the advanced screen, which shows the talk_flutter and Firebase Crashlytics in action. and it has three buttons as I also showed in the demo. Now let me quickly show you the application in action. So the application has started. Now let me quickly show you what the 15th step meant. When running the app, you will get an debug secret. Enter this in your Crashlytics in Firebase console. App check 3 let me quickly show you. Reading that is useless. So the application has started. This is the enter this debug secret into the allow list. This is the debug secret. And I closed the app by mistake. From here, this is the console. This is the three dots that I was talking about. Manage debug tokens. Add debug token. We'll paste the debug token here. And let the name be Tanish's emulator live dash emulator, let's say. Okay, save. Now the debug token has been added. Done. Coming back here. The application should start in a few seconds. Yes. So now let me quickly explain the flow. So what the code is actually doing whenever, let's say whenever the application crashes, the application sends a log to the Google Crashlytics dashboard. The Google Crashlytics dashboard accepts the log only if the SHA-256 secret key that we just added matches, and we just added the token in the manage debug token section, because while debugging we'll need to set a different token there, because we haven't set up our application for production yet. So the application is running. Let us try out the application. The application will be same as I showed you before. So let me quickly show you directly the level 3. Force a fatal crash. The application crashes, lost connection to device, and yes. So now coming back to here, we'll go to the Firebase console, the live demo, build, not build, run, Crashlytics. See, yes, you can see the error right here. This is a test crash. This is the event, and that is all for the demonstration. So now coming back to the slides, what are some other features that may come in handy? So first, don't just log vague messages like not able to connect. Instead, attach context, error codes, request IDs, target host, retries, and timestamps. Good logs reduce debugging time from hours to minutes. Secondly, don't store everything. Logs are high volume and expensive. Use sampling to keep all errors, but only a fraction of success logs. This keeps signal high and cost under control. Third, use canonical or structured logging. Logs should follow a consistent schema, same fields, same format. This makes logs searchable, aggregatable, and automation friendly. Fourth, always define a retention policy. Logs don't need to live forever. Keeping them longer than necessary increases cost and risk. Storage is not free. Fifth, logs containing sensitive data are a liability and not an asset. Credentials, tokens, or personal data should never be logged. One leaked log can become a security incident. For example, in 2018, it was found in internal auditing that even companies like GitHub and Twitter, as it was called in 2018, had the passwords of its users logged as internal logs, and later this was rectified and the mistake was corrected, and many users were even asked to change their passwords. Finally, logging should never hurt performance. Logging must be asynchronous, non-blocking, and bounded. If logging slows the system, it defeats its own purpose. Next, so this is an example. Here in this image, we can see that some columns and some data fields are written as redacted. So here we are actually hiding important data fields like email, SSN, credit card numbers that may contain sensitive information and not logging them. Here is a structured format. Instead of just logging attempt failed, this describes all the required information that may help in debugging. Next, how to avoid errors? Well, you can always fix errors when they occur, but it is always better to avoid them right from the start. So, first, use linting aggressively. Linters catch common bugs, unsafe patterns, and bad practices early, before code review or runtime. It is one of the cheapest ways to improve code quality. Secondly, write modular code. Smaller, well-defined modules are easier to reason about, test, and replace. Most large failures start in tightly coupled code bases. Third, always use secure storage for sensitive data. Secrets, tokens, and credentials should never live in plain storage or logs. This prevents both accidental leaks and exploit vectors. Fourthly, use tools like Dart code metrics and test coverage to measure code health. They help identify complexity, dead code, and untested paths, which directly correlate with bugs and performance issues. Fifth, always write modular tests and automate them in your CI/CD pipeline. If tests don't run automatically, they don't exist because they are completely useless in that scenario. Automation turns testing from a suggestion into a guarantee. Finally, keep a close eye on dependencies. Whenever you notice an outdated or unmaintained dependency in your codebase, you should immediately switch the dependency or upgrade to its latest version, as outdated or unmaintained packages are a major source of security and stability problems. Every dependency is part of your attack surface. This was all for this presentation. Thank you.